Hi, welcome to our first Year 12 revision lesson. This week we are going to do more mechanics, and the mechanics revision is going to be divided into two different lessons. The first lesson will be moments, and each lesson will be accompanied by a PowerPoint and a Word document. Most of the information can be found in PowerPoint, but if there's any information or marking scheme missing, it would be in the Word document. So our first lesson is moments, and we are going to look at how moment is being worked and being used in questions. But more importantly, we are going to look at different ways the examination board can ask you about questions about moments. So let's start. Number one, moments. Let's write it down in our notes. Sum of moments at any point is equal to 0. What does that mean? That means that clockwise moment will be equal to anti-clockwise moment at any point. Any point. Okay. What does any point mean? We'll talk about it a little bit later. Any point means any point, but we'll talk about it a little bit later. The second one that I want to focus on later, we'll come back a little bit later on that, but the second one I really want to talk to you about is the moment equals force times perpendicular distance. But what is that perpendicular distance? Between the line of action and the point. At the end of this video, in my last example question, I will go into very deep details of what that means. But right now, these two are the two things that we need to know for this particular question. So let's go to slide 2 in our PowerPoint. At question 1. Question 1 is about a truck. The truck is here, and it's got wheel A and wheel B. The center of mass is here, 1.4 meters from wheel B. So the question, we're going to focus on question 1A3. By taking moments about axle B, calculate the force exerted on the truck on each rear spring. So in this situation, I'm actually not going to, well, in this situation, there's two things that is true. Number one, because this is not moving, it is in equilibrium, that means that clockwise moment will be equal to anti-clockwise moment at any point. But I think a lot of people will forget about this point as well. That if something is in equilibrium, the forces will be equal as well. Okay, so before we go on any further, let's actually complete the force diagram. We have got a force down here. We've got two more forces. One more force will be up here, Fa, and one force will up here, Fb. And we can write down our first relationship, because we know that if force down equal to force up, Fa plus Fb must be equal to 14000. So what I'm trying to say to you is, every single time you have got a moments question, firstly consider force. And now we can start with the moment question. That question asks you to take moments from B. Actually, I'm going to prove to you every single point in here, this point, this point, this point, we can get moments from and get the exact same answer. So in a situation like this, where do we decide where to take the moments from? We always take the moments from the points with the most amount of unknown. Why? Because if you take a moment from A, the effect of Fa will be 0. Why? Because moment is force times perpendicular distance to the point, to the line of action to the point. So if line of action is here, I take moments from A, the distance will be 0. So Fa times 0 will be 0. So the moment will be 0. Just like if you have a hinge in here, if this is the hinge, I apply a force at the hinge, this thing is not going to turn. So to summarize, if I take moments from A, Fa will be eliminated, or the effect of the turning force of Fa will be eliminated. If I take moments from B, the effect of the turning force of Fb will be eliminated. So the question asks you to take moments from B. Actually, I'm not going to do that. I'm going to take moments from A if to see if that will enable us to get a better answer. Just for clarity, I'm going to rub out Fa because I know Fa in here. That doesn't mean that it disappears. It just means that Fa does not actually make a difference in our moment calculation. So whenever we take a moment anywhere, I always write down this symbol. This will actually show examiners where you take a moment from, and actually show me as well, because I might forget in 2 seconds time. Alright, so how do I determine whether the moment is clockwise or anti-clockwise? Stick my finger where I put the point from, and I pull it down. Look, this is the clockwise movement. So I go clockwise equals anti-clockwise. So I put this clockwise moment at this point, 1, 4, 0, 0, 0. Okay, I need the distance from here. The distance from here will be 2.5 minus 1.4. So that will be 1.1 times 1.1 equals, let's see if this is a clockwise or anti-clockwise moment. Stick our finger from here, pull up. Okay, this is against where the clock turns. So this must be an anti-clockwise moment. So it's Fb times 1 point, oh no, it's from this point to this point, so it's 2.5 instead. Put it down in the calculator, Fb will be equals 6160. The question is asking you the force exerted on the truck by each spring. So I can say that Fa is going to be 14000 minus 6160. So Fa is going to be 7840 Newton. 7840 Newton. Okay? So that is how you get spring the force from Fa and Fb. And they say that each wheel has 2 springs, a pair of springs. So A has a pair of springs, so each spring will have that divided by 2, but that's not moment. We're not talking about this today. But that is how basic questions that they can ask about moments. Okay, so I want you to pause the video and do slide 2. Try that question by yourself and see if you can get the same answer. And then we'll move on to the next part. Welcome back. The second part of this is when there's a second type of questions that they can ask you in an exam board, where most of the forces in the question is vertical or horizontal, and there's only one that's in an angle or diagonal. With these questions, you will need to resolve this into vertical and horizontal forces first. So let's do that first. Do a triangle here, 40 degrees, and it's 5.1. And this horizontal direction will be 5.1 sine 40 degrees. This vertical one will be 5.1 cos 40 degrees. If you're not as quick as me, pause this video and do your Sokotoa. Okay, so in this situation, what do we 100% have to do is that after we resolve these two forces, we have to eliminate this force and turn it into vertical force, 5.1 cos 40 degrees, and horizontally 5.1 sine 40 degrees. I always like to do that because if I just resolve these two forces and not eliminate that force, it will cause me a problem towards the end. So as a good practice, I will actually redraw the diagram to accommodate that. In this situation, is it all the forces? No, because we also have a force and a support, and this force will be F vertical and F horizontal. So the question is asking you to take moments to find distance D. So where do we take the moments from? Of course, we're going to take the moments from the support. Why? Because the support has the most amount of unknown forces. If we're taking moments from the support, I'm going to eliminate these two because these two does not contribute to the turning moment of this diagram, because this the vertical distance from the line of action to the the perpendicular distance from the line of action to the point is equal to 0. So let's look at these three forces. Is it horizontal, clockwise or anti-clockwise? Put your finger in here, put this down. This is a clockwise moment. Put your finger in here, put this up. This is an anti-clockwise moment. So how about the 5.1 sine 40 degrees? If you look at this thing, this actually does not contribute to the turning effect of the rod. Why? I can explain it in two different ways. Look at this pen. If I put force in here, is this going to turn? No. It is going to go forward if my finger doesn't have enough friction, but this is not going to turn. The only way that I can turn with this is applying force here or applying force here. Or actually, if you look at this plane, if I don't put this in the middle, put this in the top or bottom, maybe I will have a little bit of turning force in here. But we'll talk about it a little later. So the second way of explaining this is that the distance, the perpendicular distance from this point, the line of action for this force, and the support is 0. What am I going to, if you don't understand what perpendicular distance is yet, don't worry. My next session in the video is going to explore a lot more about this. But right now, just know that if this is pointing towards the support, the turning effect of this force will be equal to 0. So taking moment from S, clockwise moment 1.2 times 9.8 times D equal to anti-clockwise moments. And here, 5.1 cos 40, that's the force. Distance will be 0.75. And in this situation, D is 5.1 cos 40 times 0.75 over 1.2 times 9.8. So D is going to be 0.249. Let me put the forces point back up. F vertical and F horizontal. F horizontal, this force will be equal to this force, 5.1 sine 40, because force, the right hand side force equal to left hand side force because it is equilibrium. Up force equal to down force, so 5.1 cos 40, which is this force, must equal to, plus this force, Fv, must be equal to 1.2 times 9.8. Alright, so this is how you tackle questions with a force that is in an angle. But yeah, try, slide, 5, 6, and 7, and then afterwards we'll come back to the last section of the video. Right, welcome back to the last bit of the moments video. Last bit of the moments video, we are going to explore fully what does force times perpendicular distance from the line of action to the point means. So in exam, you might get one of these questions where, right, we've got vertical moment forces and horizontal forces, but the rod itself or the object you're laying moment from is not given to you. It's slanted, it's an angle, and it is a weird distance because you don't know what the distance is. So in this situation, instead of resolving the forces, which you can as well along the plane in here, we usually resolve the distances instead. What does that mean? In this question, we are doing slide 10 of the question. It is about a ladder that is on the wall, and the wall is pushing the ladder up this way. It's a very slippery wall, so there's no force downward in here. Otherwise, if the ladder falls down, that will be force upwards. But in this situation, they say that resultant force on the wall on the ladder, it is just horizontal, so that's indicating that it's a very slippery wall. Is this force diagram complete? No, because in this point, which I'm going to call this point A, this is point B, I will have a reaction force in here at A, and I also have, let's say this is vertical force and horizontal force in here as well. Okay, so how do I make this work? Where do we have the most amount of unknown forces? A or B? It's going to be A because there's two unknown forces in here. There's one unknown force in B. So we can't take moment from B because this will leave us with two unknowns. So we will have to take moment from A. With the clarity of this diagram, because we're taking moments from A, this vertical force and horizontal force does not contribute to the turning effect of the rod because the distance, perpendicular distance from line of action to the point is going to be 0. So I'm just going to rub this out just for a moment. I'll put it back in after I finish the question. But right now, this is not needed. So, what does that mean? Let's try to figure this out first. Let's, what is clockwise moment? Which one give us a clockwise moment? Which one give us anti-clockwise moment? Let's take our finger A, pull 390 down. This is going to give us a clockwise moment. So, clockwise equals anti-clockwise, because at F, it is going to give us an anti-clockwise moment. But what is the distance? Moment is force times perpendicular distance from the line of action to the point. So let's start with what the line of action actually means. Action is which direction it is. So line of action here, direction is here, so the line of action for this force will be here. So what point are we talking about? Point is the point we're taking moment from. So the point of moment we're taking from is A. So from A to the line of action, there's a perpendicular point, which is this point. This point is perpendicular. So the distance is from A to this point. One more time. This is force times distance from that line of action to the point. Line of action of 390 newtons is this line. So the point is this point. Between the line and the point, perpendicular distance is here. That's why this, I'll call this X. clockwise moment will be 390 times x. Anti-clockwise, if you know what I'm talking about, pause the video and try to find the perpendicular distance from the line of action to the point caused by F. Okay, let's start. Line of action of F. F is that direction, so I'm going to do the line of action in here. Where are we taking the points from? We are taking the moments from A, so the perpendicular distance must be from here to here. I will call this Y. So clockwise moments will be F times Y. To enable us to calculate X and Y, I'm going to exaggerate this triangle and this triangle. In this triangle, because this is half the letter, this is going to be 4 because this is the center of the letter, the center of mass of the letter. And this is going to be X. And our angle to the bottom is 60 degrees. So, SOHCAHTOA, X will be 4 cos 60 degrees. This is from this triangle. Now I'm going to exaggerate this triangle in order for us to find Y. This triangle in here. If this is 60 degrees, this will be 60 degrees as well. This is Y. And the length, this is the ladder. The length of the ladder is 8 meters. SOHCAHTOA Y will be 8 sine 60 degrees. Substituting it in the equation, so it's 390 times 4 cos 60 degrees equals F times 8 sine 60 degrees. So, put in the calculator, 390 times 4 cos 60 degrees will be F equals that over 8 sine 60 degrees. So that is going to give us 113 newtons. Okay? That's what the question is asking you. But if the question is asking you what FA have vertical and F horizontal be, F horizontal will be equal to F in here, FV will be equal to 390 degrees because up force equal to down force. Okay, you can now try slide 10 to 12. This is the end of our moment lesson. If you have any question, there's also a marking scheme for question 10, slide 10 and slide 11. There's not a marking scheme for slide 12. If you have any questions, leave it down in the comment below or in Google Classroom. But other than that, that's your moment lesson. Let's recap what we have learned. Moment is force times distance from the line of action to the point. If you apply a moment this way, it's not going to turn down the rod. Where do you take moments from? You take moments from the place with the most amount of known. We also know that the sum of clockwise moments is equal to sum of anti-clockwise moment at any point. We also know that the first type of questions, difficult questions that they can ask you, is that one of the forces is at an angle. At that situation, you need to resolve it into vertical and horizontal forces. At the second type of the difficult moment questions, the rod might be an angle as well. In this situation, we will need to find the distance, the perpendicular distance from the line of action to the point. We draw the line of action down first, figure out where we take the moments from, and draw the shortest distance or shortest displacement from the point to the action, because usually that will be the perpendicular distance. Perpendicular means 90 degrees. Okay. Thank you very much. See you later.